Why does Western music use exactly 12 notes? From Beethoven to pop songs, every melody and harmony is built from this set. The piano keyboard shows it: 7 white keys, 5 black keys, repeating in every octave. This chromatic scale, C, C sharp, D, and so on, forms the foundation of nearly all Western music. But how did we land on 12? The answer is a blend of physics, perception, and centuries of musical evolution. These 12 notes aren't arbitrary. They're a compromise between what sounds good and what's mathematically possible. To understand, we need to look at the basics of sound and how our ears interpret pitch. The story of 12 notes is a journey through science, culture, and the search for musical expression. It all starts with the octave. Play a C, then the next C up. One's double the frequency of the other. Our ears hear them as the same note, just higher or lower. The octave is music's natural frame. But what about the notes in between? Enter the perfect fifth, play C and G, and you get a pleasing 3:2 frequency ratio. Ancient musicians like Pythagoras discovered that stacking perfect fifths could generate new notes. Start on C, go up a fifth to G, then D, A, E, and so on. Each new note is born from the last. This cycle of fifths builds a scale that feels logical and beautiful, rooted in the physics of sound. The notes created, C, G, D, A, E, B, etc., form the backbone of Western scales. Our 12-note system is shaped by these natural harmonies and the way our brains crave simple ratios. Stack perfect fifths 12 times: C, G, D, A, E, B, F sharp, C sharp, G sharp, D sharp, A sharp, F, and you nearly return to C, 7 octaves higher. This almost closure after 12 steps is why we have 12 notes. If it closed after 10 or 20, our music would be built differently. The circle of fifths gave composers a palette of 12 interconnected notes, each a potential starting point for a new key. This system allowed for modulation, moving between keys, and unlocked new musical possibilities. But there was a catch. After 12 fifths, you don't land exactly on C. There's a tiny mismatch called the Pythagorean comma. This small flaw would challenge musicians for centuries. The 12-note system was brilliant, but not quite perfect. The Pythagorean comma meant that tuning with pure fifths made some keys sound great, others terrible. Musicians tried various temperaments, but each was a compromise. Some keys sounded better than others. Enter equal temperament. The octave is divided into 12 equal steps, each semitone the same size. Now, only the octave is perfectly pure. All other intervals are slightly adjusted. This tiny tweak lets the circle of fifths close perfectly, solving the tuning problem. The result? Every key sounds equally in tune, and composers can modulate freely. By the 1800s, equal temperament became the standard, giving us the musical flexibility we enjoy today. It's a mathematical compromise that unlocked the full expressive power of the 12-note system. The 12-note system is a hallmark of Western music, but it's not the only way. Other cultures use different systems. Arabic music has 24 notes, Indian music uses 22 microtones, and Indonesian gamelan has its own tunings. Even in the West, some composers experiment with microtonal music, inventing new scales and instruments. So why does the 12-note system persist? It balances variety, coherence, and practicality. It offers enough notes for endless creativity, but not so many that music becomes chaotic. It's easy to teach, works across instruments, and lets ensembles play together in tune. The 12-note system endures because it's a powerful compromise, flexible, expressive, and deeply rooted in both nature and culture.